Let's start a demo of Qinertia with Christophe Nikolopoulos.
So we are here in the main interface of Qinertia, and we're going to create a project, and I'm going to walk you through all of this. So the first thing we're going to do is name the project. I'm going to call it Qinertia Demonstration. You can then fill in your organization name, your username, and then you're going to choose where you want to save your project. Finally, you want to make sure that you select where you want to import your data from. You notice here that the motion profile jumped from marine to airplane. And that's because with our latest firmware for Equinox and Apogee and Quanta and Navsight, all of our high-end products, we have a new feature that allows you to have a file with the settings. So when you load your data in Qinertia, you also load your settings, and everything is pre-configured. But if you don't have this, don't worry, you can configure everything manually. I have 3 files here, and you can see that each one ends at the hour and starts at a new hour. And as long as these files are continuing each other, then it's okay, you can use multiple files in your project. The motion profile here is for airplane because it's an airplane application. But if you had another application, we have all kinds of motion profiles, and each one has its advantages. For example, if you use a car, then in a car application, the car usually cannot really drift on the sides. So we're going to take this into account to make the solution better. Then here in this window, I'm going to see everything that's available in the file I recorded. So here I have everything I need. I have my true heading, I have my GPS raw data, which is important for tight coupling, as you'll see. I have my real-time trajectory, and I have my IMU data, which is the most important thing. And if you have your own IMU, then that's where you would be able to load an external file. I also want to say that if you were using a car application, then that's also where you would be able to add the odometer data, or you would already have it if you logged it in real time. Here it's an airplane motion profile, so there's no odometer. In this window, I can see my real-time data acquisition, and I have the possibility to choose what I want to process. If I don't want to process the beginning of the file, for example, I can just ignore it. And same for the end. And whatever is in orange is what is going to be processed. In my case, I want to process everything. I can also do this by time selection, which allows me to just enter the beginning date and time and the end date and time. I'm now in the base station window, and in this base station window, you can see all the base stations that are available near your survey. So Qinertia will automatically choose all the best base stations to use. But if you wanted to load another base station, as long as its data is available online, then you'll be able to load it. Another thing you can do is load your own base station data. And this is very easy. You can just drag and drop your base station data directly in this window, and it will load automatically. So as I said before, you can use a base station as a single base station. And as long as you're within 10 kilometers of it, you're going to be very accurate. It doesn't mean you can't use the data if it's more than 10 kilometers away, but you can see that the further away you get from the base station, the lower your accuracy is going to be. Or you can use the virtual reference station feature that we now have with Qinertia, and you can see that it creates a corridor, and that's what I call the corridor effect. And you can see here that if I measure this trajectory, you can see that it's around 150 kilometers. And usually in real time, if you have a virtual reference station or your own base station, it's going to be only good within 10, 20, 30 kilometers of it, even with a virtual reference station, because when you create your virtual reference station, it creates it where you are located, and then you move, but your virtual reference station is going to stay where it is. So if you move too far, you have to create a new one. So here in Qinertia, it's all automatic. You don't have to worry about anything. It's all automatically created, and you have this corridor effect here for this survey that's 150 kilometers long. Each base station has information. For example, this one is GPS only, which is not ideal, but you'll see that will be very accurate in any case. Or for example, this one is GPS and GLONASS. And each base station has more information about it, like its position, that you can change manually if you wanted to, antenna information, and all the data and coverage and status that you need. Then here I can see all the base stations that are selected. And if I, for example, don't want to use, let's say I don't want to use this base station, then I can just click on it and remove it. And now you can see that my zone is different. I can also add it to my zone, select for processing, and now I'm back to what I had before and it's back there. Once I'm happy with everything I have here, all the base stations I'm using, I'm going to validate my network. What this is going to do is that it's going to do a PPP computation on each base station, one by one. And this is usually done over a period of 24 hours of data that is usually available online. And it's going to make sure that each base station has the position as accurate as possible, because it's possible that a base station is not up to date online and the position is too old and you're going to have an error. So here we do a PPP computation on this data and we're sure that everything is accurate. Once this is done, I can see here that it says everything is consistent. So I can move to the next window. My settings file told me that it's an Apogee G, so I don't have to set anything in there. It's already selected. If I didn't have this settings file, I could select it manually, and I'll show you this later. In this window, you can change your orientation. If, for example, your system was installed upside down during the survey and you forgot to tell it was upside down, then your whole survey is going to be messed up. But if you load the data in Qinertia and then correct for this orientation in there, everything will be good in Qinertia. You can enter some lever arms to the center of rotation, for example, or to a monitoring point, which can be a camera, or LiDAR, anything you want. And in this window here, you're going to have your GPS information on your rover. So you have your lever arms that were entered in real time. You know it's a septentrial GPS receiver. And you could enter information here on your antenna if you wanted to. But I don't really trust these lever arms because, you know, they were measured with a tape measure and it's not always accurate. So what I can do is uncheck this little button here. And I'm going to say that my lever arms have not been measured with an accuracy better than 1 centimeter. That's why I'm unchecking this little box. And this is going to allow Qinertia to post-process the data and re-estimate the lever arms and tell me if my lever arms are good or not. So I'm going to uncheck this little box for now. Finally, in this window, I can see everything that's available in Qinertia. And this is all dependent on what I configured before. For example, here loose coupling is available as long as you have your real-time data. And what it's going to do is forward, backward, and merge, like we've seen. It's not going to add a base station. It's not going to do anything additional. But still, if you have SBAS in real time, you can still have something maybe 3 times better in post-processing just by doing forward, backward, and merge. Then we have loosely coupled PPP. And loosely coupled PPP is in case you don't have access to any base station, but you still want to be accurate within 10 centimeter. This is only useful if you're in an area where you don't lose GPS because it takes a long time to compute. So you want to make sure that you don't lose GPS during your survey. So this is mostly used for airplane application or for offshore application where you're too far from the shore to have a base station available. We have the tight coupling Ppk, and this is the best solution you can achieve. This is doing same thing, forward, backward, merge, but adding this base station that we selected earlier. And this is going to give you in the centimeter level accuracy, even if in real time you were in SBAS and had 60 centimeter accuracy, for example. We have the reprocessing. This is only used really for R&D, where we do a forward processing only, nothing added, no backward, no merge. And this allows you to see what would happen in real time if you change your level arms, for example, or your orientation. So really useful for R&D, not really useful if you want to do post-processing. Finally, we have GPS-only processing or GNSS-only processing, where we can do PPK and PPP. Once I'm done, I have my map. I can see my zone here, and I can see my trajectory. And I can see that it's color-coded. Red usually means that it's bad quality. Green means it's the best quality. Blue is in between. And I can change also this if I want to change my layers, for example, to show a grid or to show a road with something like Google Maps, for example. But I can also change my data if I want to display it by quality or position type. And here you can see that most of the time we're in SBAS. In fact, what I can do is I can show you here the solution type for the whole data. And 89% of the data is going to be in SBAS, but 10% of the data, around 10% of the data is going to be GNSS velocity. And that's probably because the GPS during these times was not really available or accurate. I can also show some graphs on my position accuracy. And I can see here that on average, I have an accuracy of 45 centimeters. And I have a maximum error of 2.5 meters, which is not negligible. I can also graph some accuracies here. And for example, if I graph my standard deviation for position and angles, I can also move them around. So if I want to move them, I can do this. And each of them, I can do a screenshot that I can then use to put in my save to a file or put in my report, for example, by copying to clipboard. So let's see what we have here. So my angles, you can see that it takes some time where we're static at the beginning to be accurate, but we have an accuracy of maximum 0.03 degrees here. And if I check my position, you can see some jumps here to 2 meters, but overall I'm between 20 and 25 centimeters. Okay, so now that I have this, I can process my data and estimate my level arms. So we're going to start by doing a pre-processing. The pre-processing is going to be done on each base station and on the rover to see if everything is all right with the GNSS reception, because maybe there is some issues with the GLONASS constellation, but not with the GPS constellation. And so this is going to be here in this pre-processing report. Okay, so I have my report on the rover. I can see, in fact, there is a warning here. It computed, so here it's missing 5 epochs, which is okay. You can see that it's on the GLONASS, that there's something. But otherwise, my base station and everything else seems to be good. So that's good. And you can use this in your reports also as quality information. Okay, you can see here that we do forward and backward at the same time. And this is what we call multi-threading. It's a computation method that saves a lot of time. We do everything at the same time, so forward and backward here. But you notice that we do 3 forward and 3 backward. And this is to have even more data to use in the merge to have a better accuracy in the end. So While this is going on, let me show you all the base stations that are available in Qinertia. So you can see here that all these base stations are available. Of course, depending on the countries. For example, in Japan, you might need to have an account to access the base station data with their network. And it's okay, you can access it directly in Qinertia too by entering your account username and password. But here in the US, most of the base stations are free. And if I zoom in here, you can see there's a lot of base stations everywhere. And if I select a base station, it's going to give me some information. For example, here, its name, the provider, the constellations that are used. And if I click on more info, then it's going to open the base station window and the base station website, and it's going to give me more information on this base station. If I want to download the files directly from that website, I can do it. If I want to see some pictures of what the base station looks like, I can do this. So a lot of things are possible in this window. And of course, you can also access this information in Qinertia, and I'll show you. But here we're finishing our post-processing. So we're finishing our third forward backward, and you can see that if I zoom here on the time scale, it zooms horizontally, but if I zoom in on the graph, it zooms in vertically. And you notice that we're only displaying the forward processing here. That's because it would be chaos to display both forward and backward at the same time. So the first time we do it, we only display forward, second time only backward, and third time only forward, but we do them at the same time, of course. Okay, and now that this is done, we do the merge. And you can see the merge is doing the same, using the same method, multi-threading, to merge a lot of parts of the data at the same time. This also saves a lot of computing time. So now that this is done, I have my estimated lever arms. And if I check it, if I check them, I'm not too far. Here you can see 2 millimeters. Here we have around 3 centimeters. And here we have, it's the most we have. It's around yeah, 9 centimeters. So I can choose to use these lever arms or not. It's up to me. I'm going to use them because, of course, that's why I'm re-estimating my lever arms, is because I don't trust them. But what we usually suggest to do is to do a few of these lever arm estimations so that the current lever arm, little by little, will converge to the estimated lever arm. Once your current lever arm and your estimated lever arm are the same, then you know that everything is perfect. There's also an estimation on my pitch and yaw angles between my two antennas, and this is also very important. So I'm going to select these, and you can choose to automatically relaunch your processing once this is validated to use these lever arms. And of course, I always recommend to do one last processing using the lever arms and not trying to estimate them, because you want to have the best data possible. But here, I'm not going to automatically relaunch the processing for the sake of the demonstration, but I'm going to use these. And so now that my lever arms are selected, you can see here that we have access to our settings that we use. So for example, here my base station that I selected, in case I, in the end, want to remove this one because it's GPS only. And you can see that if I go here in my providers, that's where I'm going to see all my providers available. And I told you about Japan earlier. That's where you would set your credentials. But I also have access to my configuration. I can change my motion profile. I can change my IMU. Let's say I didn't want to use, in the end, it was not an apogee. My file had a mistake in it. Then I can change this. Or if I did a mistake manually, I can change this. And I can change my lever arms. So you can see here, the lever arms I have now are the new lever arms. And it says here that I trust them. So if I wanted to re-estimate my lever arms, I would uncheck the box here again and relaunch your processing. But here, I trust them. Okay, so now we can check our data and compare with what we had before. So if I open my same position statistics window, I can see that now on average, I'm 2.73 centimeters accurate. Before it was around 45 centimeters. So it's a huge improvement. And my maximum error here is maybe 6 centimeters at the maximum, around 6 centimeters, whereas before it was 2.5 meters. So it's a huge, huge, huge improvement. If I check my angles here, if you remember before, well, in fact, I'm going to show you here. This button here allows me to graph, display, choose what I want to display. So I'm going to display here my origin data, and I'm going to display my same accuracies that I have here. Okay. And so now if I compare, I can see that before it took some time to converge, and then my accuracy was around 0.3 maximum, whereas here my maximum, sorry, 0.03, whereas here my maximum is what, 0.015 for my heading, and my roll and pitch are very accurate. They're they're below 0.006. If I check my position standard deviation, I can see that I don't have any more these big jumps here to 2 meters. And before I had between 20 and 25 centimeters, which is now between 1 centimeter and 3 centimeters. So around 2.5 centimeters. So this is pretty good. It's 10 times better. Okay, I can also display my solution type, and you can see, I first have to switch, of course, to auto merge, and my solution type, you can see, is 87% of the time in PPK fixed. Before it was SBAS, and now the rest of the time it's not velocity, GNSS velocity anymore. Now we're in PPK float. So now that I'm happy with my data here, I want to export it, and I want to make sure that I use this data, this new process data, in my project. So to do this, I'm going to go here, File, Exports, and I'm going to open here a new profile. I'm going to call it Qinertia Export Demonstration. And I can export 3 types of files. I have a KML exporter for if you want to export a file to Google Earth and see your position in 3D. I can use the SBET exporter if I want to export an SBET file, and this is going to be used mostly in softwares like HiPAC or QPS or PDS 2000, for example. Or I can do a text exporter, and this allows me to export a text format that I'm going to design myself, and I'm going to show you. I can choose my datum, and if I don't want to use WGS84, for example, I want to use NAT83, then I can just select NAT83, and I have a transformation here that's going to be used. If I want to create my own datum or my own transformation because it doesn't exist for some reason, I can click here, and I can create my own transformations, datums, and ellipsoids. Here I can select my lever arm location. If I want to export everything at my IMU, then by default, that's what it is. But I also had a lever arm entered before that goes to the LiDAR or to the camera, and I can use this to export the data to that lever arm. I can also export the data up to 200 Hertz, but in this case, for the demo, I'm going to export everything at 1 Hertz. I can choose where I want to export my data, how my data should be named, and what I want to put in my data. So I'm going to click here, and you can see that you can build your file. So I'm going to build it with my time and date, for example, here, UTC date, UTC time. Oof, you notice that it's GPS time of week. I'm not a big fan of this. I want hours, minutes, seconds. So here, I can go here, and just select hours, minutes, seconds. And you can easily change the units for your fields. And now you can see it's hours, minutes, seconds. I also want to know what these are because it's confusing here. So I'm gonna add a header, and I'm gonna say that I want to see my name and units. And now I have my header. I can also add anything else I want for my header. And then I can add my navigation, for example. So position, latitude, longitude, my altitude, mean sea level, above mean sea level, and oh, I want ellipsoid in the end. You can just drag and drop and just put whatever you want in there, and of course change your units. If you want your altitude in feet, for example, you could do this. Once I'm happy with this, then I can export this data. But before we do this, I want to show you that it's also possible to export some data in Nmea format. So it would be very easy. You can just add your data, and you can also add some new line feeds that allows you to have everything one line under the other. Once I'm happy with my data, I'm going to click OK, and I can start my export. So it was very quick because it's 1 Hertz. And if I click on it, then you can see here the data.
So that's it for the Qinertia demo. Thank you for watching it, and don't hesitate to contact us if you have any question. Talk to you soon!